Earth is pulling on this rocket with the force of an entire planet. So how does a machine built by humans break free from that invisible grip? Here's something most people don't realize. Rockets don't escape gravity by going higher. They escape it by going faster. It actually takes more energy to escape Earth's gravity than to travel to the Moon or Mars. And today, you'll find out why. Earth's gravity is one of the most powerful forces we experience every day, and it never turns off. Right now, Earth is pulling you, the air around you, the oceans, and every rocket ever built toward its center. If you throw a stone upward, no matter how strong your arm is, gravity always brings it back down. So when we see a rocket lift off and leave Earth behind, the real question isn't how it goes up, but how it manages to escape the pull of an entire planet. Gravity exists because Earth has mass. According to Newton's law of universal gravitation, any object with mass attracts other objects with mass. Because Earth is so large, its gravitational pull is strong near the surface, accelerating objects downward at about 9.8 meters per second squared. This means that every second an object is falling, it moves faster and faster toward Earth unless something counteracts that pull. For most of human history, gravity kept us permanently grounded. That changed in 1957 when the Soviet Union launched Sputnik 1, the first artificial satellite to successfully reach orbit. Sputnik didn't escape gravity entirely, but it did prove something remarkable. With enough speed, an object could fall around Earth instead of falling back to the ground. This discovery marked the beginning of the space age. A rocket never truly escapes gravity in the sense that gravity disappears. Earth's gravitational pull weakens with distance, but it never reaches zero. Instead, rockets reach a critical speed known as escape velocity. Escape velocity is the minimum speed an object must have so that gravity cannot pull it back, even if the object stops using engines. For Earth, escape velocity is about 11.2 kilometers per second, or roughly 40,000 kilometers per hour. Achieving this speed is far more important than reaching a specific height above the planet. To reach extreme speeds, rockets rely on a fundamental principle of physics known as Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. Inside a rocket engine, fuel is ignited and burned rapidly, producing hot exhaust gases that are expelled downward at very high speed. This downward action creates an opposite reaction force that pushes the rocket upward. As long as the engine continues burning fuel, this reaction force keeps acting on the rocket, allowing it to accelerate higher and faster. With less mass as fuel is consumed, the rocket gains speed even more efficiently. Rockets are built in stages to use fuel as efficiently as possible. At liftoff, a rocket is extremely heavy because it carries massive amounts of fuel needed to fight Earth's strong gravity. As the engines burn fuel, the rocket's mass decreases, allowing it to move faster. When a stage runs out of fuel, it is detached and falls away, removing dead weight. This makes the remaining stages lighter and more efficient, enabling the rocket to accelerate to much higher speeds. Staging is critical because without shedding empty fuel tanks and engines, a rocket would not be able to reach the enormous speed required to overcome Earth's gravitational pull and continue its journey into space. There's no invisible line in the sky where Earth's gravity suddenly stops. Instead, gravity slowly becomes weaker as altitude increases, but it never fully disappears. This is why rockets do not escape Earth by traveling straight upward. Shortly after liftoff, rockets begin to tilt and accelerate sideways, building tremendous horizontal speed. This sideways motion is essential. When a spacecraft moves fast enough sideways, it continually falls toward Earth, but keeps missing it. This endless free fall around the planet is known as orbit, and it is how satellites remain suspended above Earth despite gravity constantly pulling them downward. Orbiting Earth is not the same as escaping its gravity. Objects in orbit are still strongly influenced by Earth's gravitational pull, which is why astronauts experience weightlessness. They are constantly falling toward Earth, but moving forward so fast that they keep missing it. This continuous free fall creates orbit. To truly escape Earth's gravity, a spacecraft must reach escape velocity, about 11.2 kilometers per second, in the right direction. This is achieved not by going straight up, but by combining upward lift with immense horizontal speed that allows gravity to no longer pull the spacecraft back. Escaping Earth's gravity is one of the most energy-demanding challenges in spaceflight, often requiring more power than traveling between planets once already in space. Earth has a deep gravity well, meaning a spacecraft must expend enormous energy just to climb out of it. To achieve this, rockets carry massive amounts of fuel, so much that over 90% of a spacecraft's launch mass can be fuel alone. Most of that fuel is burned in the first few minutes after liftoff. Once the spacecraft has overcome Earth's gravitational pull and reached the required speed, moving through space becomes far more efficient, allowing it to travel vast distances with relatively little additional energy. When you watch a rocket launch, you are witnessing an extremely precise battle against gravity. Every second involves careful calculations of mass, thrust, speed, and direction. The rocket is not simply flying upward, it is accelerating sideways, shedding weight, and balancing forces with incredible accuracy. Gravity never stops pulling, but through physics, engineering, and immense energy, rockets are able to break free from Earth and begin their journey into space. Escaping Earth's gravity is not magic. It is one of humanity's greatest scientific achievements, built on centuries of understanding motion, force, and energy, and it all begins with going fast enough to let gravity lose the fight.